All right. So I was listening to a recent Jason Sweat podcast, and they were talking about flaky tests, which is what he's kind of showing in this article here. And they kind of verbally talked through some of it, but I figured I could show kind of what this looks like in some code examples. So I've got an extremely simple app. I've got just done Rails new to set the thing up. I've got a few models and a few model specs. Most of them are commented out, and we're going to step through them. And for this, I'm using rspec for doing the tests. So if I come in here, I can run my tests, and I see my one test, which checks that 1 is equal to 1, is true. So that's a good place to start. If I run this a few times, we'll see that it keeps on passing. Cool. Now, I've added another little something here, which has a method called super flaky, which if I run this now, passes. So we're great. This is golden. We're perfect. This is good. Oh, turns out this function is flaky. In fact, if I do this other one here, which is probably slightly more realistic, though not really. If I run this, we'll see that we now get the last one fails. So this is the do stuff is failing. If I run it again, super flaky failed. If I run it again, nothing failed. And if I run it again, both failed. So those random ones turned out they fail. So they talked about looking at the code, kind of seeing if there's some sanity checks that you can do in here. And in this case, they're pretty obvious what's the problem. So this one that's super flaky, if a random number random number up to 10 is greater than 3, it's going to fail. If this one's greater than 1, it's going to fail. So this is going to fail 10% of the time and 30% of the time. So that's where this flakiness is coming from. So with this, this is pretty straightforward, but this is where randomness will bite you. So this obviously is super contrived, but the problem here is that we're doing a test where we are expecting a stable outcome from a random functionality code that runs random. So that's where it gets to be a problem. Now, if I come in here and say, how can we fix this? So if we have something where we can't remove the randomness, and I'm gonna just comment to this one here. So we're just working with this super flaky one. So if we run this, we can see it fails, and that's basically because this random is gonna be random. So one thing to remember is that with randomness, there is no randomness in computers. They have a few things that can bring in randomness. This has to do with like lava lamps and stuff like that, but at the exact time. But we can actually grab that and make the system not random. So if I come in here and I just do srand 1, 2, 3, this means that we're going to give it a random seed of 1, 2, 3, and it's going to tell us what that seed is that it was using originally. I'm just going to put that out. So if I run this again, we can see the actual seed that it's using is this big gargantuan thing. So I'm going to put that in here. And what I'm going to do now, so if I were to run this again, actually let me do that. So if I run this again, it's going to give us this new seed of, I forget what it was before. So this number is random every single time. And in fact, we'll get that in seeds in a second. So what I can do is I can just grab this seed. This actually is a failing seed. So we're actually going to get one that passes. Sorry, that 1, 2, 3 is always, yeah, I grabbed the wrong, we'll comment that out. So actually, let's put this back in. Okay. So for this, we can grab, so the 1, 2, 3 seed, it fails. So if I set this to that big long number and run it again, okay, this seed number does pass. So we're good. So what we're going to do here is we're going to set the random seed to a certain number, and we're going to save that. And then after we run our tests, we're going to reset that back to that original seed. That way it doesn't really affect other things. Now this you'd probably want to build it in some sort of a before block that will take care of it for you and whatnot. But if we run this again, we can see it passes. Great. So what we've done is for this test, we're still going to leave everything random, but we're able to cement in place what this random number is. Now this probably is a smell. It probably means there's something else you should be looking at. But if you have something that truly is random, this will take care of it. Let's load up this next one. So here we have a time failure, and we say, actually, let me change this. February has 28 days. So we run this. It works great. It works great. It works great. And we say how many days are in February. It says 28. Beautiful. And then the counter flips over and it's January 1st, and all of a sudden it fails like this. We've got 29. Well, that's happening because this year is a leap year. So let's take a look at the code and see what this looks like. All right, so it gets the current year, and it says how many days are in the month of 2, so February, for 2024 currently. And it's because it's a leap year, we have 29. So this is the problem here. So we could do something like, in here we're saying, maybe we could do something like this. So we could inject the year like that. If I run this, it's going to still fail. But I can say I want to know the days in the year of 2023. And now it says 29. Now, that's one way to do it, is where you can inject and say that the year. So now we're making this into a static year. We also use some other tools to freeze time. Time copy would be one, for example. So we actually say it is currently 2023, and then run this code. So there's a few different ways we could tackle it depending on what we're trying to do here. So this is using, this would be called dependency injection. So the code depends on what the year is, and this is going to change it to so that we can inject what the year is, and this lets us do it through the test code only. So if we run the full test suite, we can see everything's still passing, so that's a good sign. All right. And this is the next example is a race condition. So in here, this is going back to Jason's example. We're going to be doing a pickup. The prep time is 13 to 15 minutes. The drive time is 10 to 16 minutes. And we expect that this to be successful. So if we come in here and run this, ooh, it fails, and now we're raising obscenities. If we run it again, it's successful. And if we run it again, let's see if we get more obscenities or not. We are getting more obscenities. Okay, so what's going on here? So if we take a look at the code, so what I'm doing is I'm making a thread, and I'm sleeping for the prep time. I'm making a second thread, and I'm sleeping for the drive time, and I'm using just a compression here, so we have to wait only a few seconds instead of a few minutes. I then drive until we're done, so this is going to make sure that's done, and then I'm going to check the status of the prep thread. If it's done, then I'm going to be true, everything's great, otherwise I'm going to raise obscenities. So there's a few problems with this. This is kind of a weird structure, so like we can ignore that. But the bigger problem on the test side of things is that we're not really like we're trying to do something deterministic, which is we should be able to pick them up, but we aren't setting that up properly. So let's make some changes here. So with this, we can say, okay, well, let's get a context. So the context is ready in time. It's true. Well, for this to be true, what's going to happen? So what I'm going to make my prep time, I'm going to make that 5 minutes to 10 minutes. And my drive time is going to be 11 minutes to 16 minutes. So when my prep time is definitely going to be before my drive time, then we're good. Let's see if this works. So it doesn't fail. Great. And we can basically copy this over and let's do the opposite. So let's do not ready in time. It's so here's where I'd probably be a little bit critical of this and say this should be returning false or something like that. But we'll say we can't change that. So when it is not ready in times, then obscenities occur. And I'm not going to spell that off the top of my head. Which is terrible, but that's fine. So we're going to say expect that to raise, what is it, raise exceptions? I think that's it. We'll see. All right. Now this one actually runs slow because it's waiting for a few seconds, and let's actually fix this. So prep time is going to be 10 minutes to 15 minutes, and the drive time is going to be 5 minutes to 9 minutes. So with this, what we're actually doing, now it's complaining we should be using a better matcher. That's fine. You'd want to actually have this a proper exception. That way you're not just globally grabbing everything, but that's really kind of beside the point of this. So in this example, we've actually eliminated because the single call that we were doing here originally was non-deterministic. What we've done is we've split it so it is deterministic. So that's the improvement that we make with this. And if we test things again, we're going to get all passing. Great. Now they were flaky, so they might just be getting lucky, but who knows? All right, we'll find out. So here's our next one. This was a network issue. So here we will say that it's true when it does stuff. So that's a nice little test, and let's run it. And it fails right away. And if we run it again, it passes. Okay, well, what's happening here? So in here, we're hitting HTTP status website, asking for a random status, and we're saying give me a 200, a 200, or 200, or a 500. So 75% of the time, we're going to be 200. We're going to be good. So we're just checking here the request code. The status code is a 200. So with this, I'm not going to go into extreme detail, but what we'd want to actually be doing here is we actually want to wrap this in something where we do a mock or a stub, a tool that's going to mock out the networking layer. So this would look like something like VCR. So with that, we could hit the endpoint for real, record the results, and then play it back, or we could do something where we provide a fixture where we have a built-in successful, unsuccessful one, and then we would actually have in here a context where we say, you know, if it's a unsuccessful, we do this, it's false. If it is successful, it's true. So this one I'm actually not going to fix, so I'm going to leave this commented. I'm going to leave this pending. So if you throw an X onto a test, it actually will just skip it, and it will actually if we run this, we're going to see that it's a pending test. So we're still going to yell that up because the obscenities one, but we can see here that we have one pending test, which is great. It means we need to come back to it. All right. And so for our final one, this one is fun. So we've got this leaky one. So if I go in here and I make B, turn that on. If I turn on A, and I'm actually going to go into that race failure And I'm going to comment this out because it's slow. So in here, the one failed. They're expecting Jonathan. They got a Jonathan bomb. If we go and run it again, it fails again. Now it passed. This is probably a great example of what you'd see if you were looking at Circle CI or something like that, and seeing a flaky test failure there. So what's happening with this is, so if we run this, so with this we actually have a few tools that we can use to help us with this. So if we run it, okay, this time it did fail. So if we scroll back and look, we can see this randomized with seed. What this means is that the order of your tests are random. So with this, it's going to fail if we run. So what I'm looking for with this, if I go in here, I do rspec seed and that number, it fails, it fails, it fails. So something about this order of the tests causes it to fail. Now we can see that it has, so that has the pending one at the end. It has all these 4 in front of it that could be doing something that's leaking something that's giving us a problem. So if you have something, if you run on Circle CI, you get a flaky test, it will give you that seed. If you can run it on your computer, and if it fails and fails and fails, it's wonderful. It actually means that you have something you can work with pretty easily. So with that, if we come in, we can come in here and do a bundle exec rspec seed, and we're going to do a bisect on this. So what bisect's going to do is it's going to run your test suite, see what fails. And then what it's going to do is it's going to get your test suite, cut in half, and check it, see if it passes. Check the other part, see if it passes. Whatever side fails, it's going to grab that section, cut in half, test it. Cut in half, test it, cut in half, test it, until it finds the minimum amount that causes it to still fail. So right now it's running all the tests. So right now it's running 6 tests. If I do this, it's going to go through. So what we can see here is that it's going to start with the seed. It's running the suite to find failure, so it runs it in half a second because it's tiny, and it failed. It's then starting with a bisect, 1 failing example and 5 non-failing. It does a round. It does 1 through 5, ignoring 4 through 5, and then it does another one, ignoring 1 and 2, and it's complete. So it reduced all of it down to this one command right here. So with this one command, we can put that in, and we can see that we're running 2 tests. So this isn't even 2 test files. It happens to be in 2 test files. But if you had, if these actually had like 15 tests inside of them, it would say, no, these 2 specific things seem to cause an issue. So when I run this, it runs the first test and it's successful, runs a second test and it fails, and that's failing on the leaky failure A spec. So if we load this up, we can say that this is failing because something that's happening in leaky failure B. Let's take a quick look at leaky failure A. So in here, I'm just taking a first name, an optional last name. It gets a first and last name, throws them into add a reader, and then it's going to do a compact for the full name. It's going to be a compact blank and joining them together. So when we do that, we can see that it's expecting Jonathan to be Jonathan, but we're getting Jonathan explosion. Okay, so something about leaky failure B is giving the problem. So if we hop over to, then this passes over here. So over here, this is not probably going to tell us too much. There's nothing weird going on in here. But if we look at leaky failure B, leaky failure B is doing something in an environment. This is something that's going to stick around between tests. So this is where we are leaking. Now this is pretty obvious because it's right in our face and we're using a bomb emoji. But that's kind of what we're looking for when we're doing something like this. So if we look at here, you can see that it's being deceptive. And if we scroll down, the last name has a default value of environment stuff. So this here is how we are leaking from this test into this test. So the solution to this problem probably is to do something where we move this up into the initializer or something. This is obviously pretty contrived, but yeah, we'd want to do something like that. So let's just say that's what we would decide. Yeah, this should be getting that from the initializer. So if we do that, and then we run the tests again, and so it's still bringing that in, and then we probably want to say, yeah, Jonathan. Bennett is equal to Jonathan Bennett. That's really not testing that. And this doesn't have much intention, so I don't know. So because I don't really know what I'm supposed to be testing here, like if this is testing that it concatenates properly, then this would be probably a better test. If I'm testing that it has a default last name or something like that, that probably makes sense. Actually, so even for this, having a default last name probably doesn't make sense. So having that in our thing at all is probably the bug. So we probably would say nil. We've gotten rid of it down here. And that now passes. And if we run the whole test suite, besides that one that's pending, everything passes. So with this, we've kind of looked at a leaky test. We've looked at something that's dependent on times. That's our February one. We've looked at a race condition where we're using threads to have things come in at different orders. And with that, we wanted to split those up to make them deterministic. For the networking one, that's where we'd want to use a tool like VCR or WebMock to basically keep all the tests the same, but we actually would want to make the results from the server be consistent. And is that all of them? Network, race condition. Oh, and randomness. Yeah, we just wanted to make that again deterministic. So that kind of addresses the major areas that cause flaky tests with kind of a specific example. All right, take care.